All right, we're going to go ahead and begin. We're going to be looking at the review number 1 that can be found on the review packet that had the 10 little mini 5-question reviews. And we're going to go through this first review together. Okay, so I'm going to work out the problems and hopefully these will make sense to you and you'll remember how we've seen these before and just kind of bring them back, refresh them in your memory to help you better prepare for your exam tomorrow. So first problem tells us to solve 4x or 4 times x plus 3 minus 5 equals 2x plus 8. So we're going to distribute here. 4 times x makes 4x. 4 times 3 makes 12. Then take away 5. That equals 2x plus 8. I'm going to simplify the left side a little bit more. 12 take away 5 makes positive 7. So we get 4x plus 7 equals 2x plus 8. And then we're trying to solve for x here. So what we have to do is isolate the x variables, get them by themselves. And right now there are x's on both sides. So this is where we cancel the x's on either the left or the right. So I'm going to take away the smaller number of x's. That's going to leave 2x plus 7 on the left side. And then that 2x that was there on the right now goes away, just leaving 8. Then we'll take away 7 from both sides, leaving 2x equals 8 minus 7, which is 1. Divide by 2. Since that is a smaller number on the top, that means we're ending up with a fraction, which is just going to be 1/2. Okay. We've talked about also if you were using Desmos. Now this one says non-calculator, but if you could have used Desmos, you could have just graphed 2 equations. Graph the left side, y equals 4 times x plus 3 minus 5. And then graph the right side, y equals 2x plus 8. Just basically split up the equation into 2 y equals equations. Wherever those intersect, the x value at that point is going to be 1/2. It's going to be the solution to the equation. Go ahead and take a look at number 2 now. This one tells us to graph the system. So we have a system, and these aren't equations. Notice the symbols we have here. We've got some inequalities, okay? Because we've got this less than or equal and greater than or equal symbol we see here. So what we're going to have to do is find a way to graph these on this particular grid, or at least be able to identify the graph. Now, on your actual exam, it's probably going to give you 4 different graphs, and you have to pick the one that matches if there was a question like this. But if we were graphing it by hand, what we would do is we would look for the slope and y-intercept. In the first one, we have a y-intercept of -4. So we'll go put a point at -4 down here. And then the slope is +2. Now that's a whole number. Remember, that means we go up 2 and over 1. Up 2 and over 1. Do that each time. So if I go up 2, 1, 2, and over 1, I put a point there. Up 2 more, over 1, up 2 more, over 1, and just kind of keep repeating that to get the shape of the graph. Then I can also kind of go back to my y-intercept and go down 2 and backwards 1 to put another point here. So that's the direction this line is going to go. Now it does have an equal sign to it, which means when I graph this inequality, remember, if it has an equal sign, you want to draw a solid line through those points. So that's what we'll do here. If it didn't have an equals part, if it just said y is greater, then we would have drawn a dashed line, okay? Something that looks like that. But this one was less than or equal, so we put the line. Again, what that means is points on the line are considered solutions here. Now, the last part is we have to shade one side of the graph or the other. And again, when we discussed this in class, we talked about picking a point, a really easy point, and then plugging in the numbers from that point to this inequality and seeing if it's true. So what I mean by that is I would take y is less than or equal to 2x minus 4. I want to pick a really easy point like 0, 0, and plug in 0 for y and 0 for x. And then see if this is true. So 2 times 0 makes 0. 0 take away 4 makes -4. And now that we just have 2 numbers with an inequality in the middle, we check to see if this is true. Is 0 less than or equal to -4? It's clearly not equal, but it's also not less than -4. 0 is greater than all the negative numbers. So this is not true. And what that means is that the point 0, 0 should not be shaded in, okay? So because 0, 0 is sort of above this line on the top left, we want to go back and shade everything on the bottom right, everything that's on the other side of the line. Okay, so that would be how we graph y is less than or equal to 2x minus 4. Now, we're going to go graph the second one. I'm going to switch colors here. This one is not in slope-intercept form, though. Notice how it says 2x plus y is greater than or equal to 9. So what I could do is go ahead and pause for a minute and try to get this in slope-intercept form. In other words, get the y by itself so that I can see the slope and the y-intercept. To do that, I'm going to take away 2x from both sides. It's going to leave y is greater than or equal to 9 minus 2x. Please remember, the only time you have to adjust your solving steps is if you ever divide both sides or multiply both sides by a negative number, just remember to flip that inequality symbol to face the other direction. But we didn't do that here. We just subtracted. That doesn't change it at all. So this is what we end up with. So our y-intercept would be 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9 would be like way up here. And then we have a slope of -2. That means we're going down 2 over 1. Again, it's a whole number. If I was to write it like a fraction, it would look like this. The top would tell me whether I go up or down and by how much. The bottom number tells you how far you go to the right. So this is down 2 and over 1. That would put me here. Down 2 more and over 1, down 2 more and over 1, down 2 more and over 1, and just keep repeating that process. Okay. Now this also had the equal sign in its inequality. It was y is greater than or equal to 9 minus 2x. So I'm going to draw a solid line again. I'm not actually going to, not going to draw the line off the graph. So I'll just pick up with the first point that was actually on my grid. Looks something like this. Okay. And then I'm going to take that inequality. I'm going to plug in my basic point 0, 0 again, and then see if that needs to be shaded in or not. So if I plug in 0 for y and 0 for x, I'm going to get 0 is greater than or equal to 9 minus 0, which means 0 is greater than or equal to 9. So 0 is not equal to 9, so that's not true. And it's also not greater than 9. So none of that is true. 0 is not greater than or equal to 9. So that means, once again, don't shade the side of the line that has 0, 0. So I'm going to end up having to shade over here, the other side of the line. And now, because this was a system and we graphed 2 of these, that means there is a section of this graph that is the solution to both of them. And that's the part that's overlapping red and blue. So that would be all of this stuff over here. This is where the solution to the system would be. And it would be points on those lines or points in that shaded area that's just colored in by both of them. Okay, so that would be the solution to this system. Okay, take a look at number 3. For what positive integer value will 2 to the x first exceed 3x plus 2? Let's talk about these words. Positive, we know what that means. Any number bigger than 0. And integer values, that's like whole numbers. Okay. But again, technically integers can be positive and negative. That's why they're saying positive integer values. If they wanted to talk about just positive ones, you also could use the word whole. So technically here, they could have said, for what whole numbers will 2 to the x first exceed 3x plus 2, but that's what a positive integer is. It's just a whole number. So what we're going to keep track of is we're going to keep track of x, like different numbers for x. And we're also going to look at what 2 to the x would be and what 3x plus 2 would be. Okay, we could think of these as functions, like maybe call this f of x and call this function over here g of x. And then the idea would be, when will f of x first exceed? We need to know what exceed means. Exceed means is greater than, right? So what's the first whole number, the first positive integer, where 2 to the x is exceeding, is greater than g to the x? So let's start with these. Now, it did say positive. That means it does need to actually be bigger than 0. So we'll start with 1. 2 to the first power, that's 2. We plug in 1 for x on this other function, we get 3 times 1 plus 2, which is 3 plus 2, that's 5. So is 2 to the x bigger than 3x plus 2 here? No, 2 is smaller than 5, so we haven't exceeded it yet. Let's go to 2. 2 squared makes 4. Plug in 2 to the other one. 3 times 2 plus 2 makes 6 plus 2, which is 8. Is 4 exceeding 8? Is it greater than 8? No. So do it again. 2 to the third makes 8. 3 times 3 plus 2, that makes 9 plus 2, which is 11. Is 8 exceeding 11? No. Keep going. 2 to the fourth. That means just multiplying by an extra 2, right? That's how I came up with those first numbers so quickly. So 2 to the fourth is just the same thing as 2 to the third, but times 2, which makes 16. Then we do 3 times 4 plus 2, which is 12 plus 2. That's 14. Does 16 exceed 14? Yes, it does. So for what positive integer value will 2 to the x first exceed 3x plus 2? That answer is going to be 4. 4 is the first x number we can plug in that makes 2 to the x bigger. All right, number 4. Simplify 16 to the 1/2 raised to the 4th and divide that by 2 to the 8th power. Okay. So let's break this down. First off, anything to the 1/2 power, we can actually try to simplify first by remembering that a 1/2 power is the same thing as a square root. So 16 to 1/2 is just the same thing as the square root of 16, which is equal to 4. So I could replace this whole inside part right here with just a number 4 and say, okay, that's 4 in the parentheses to the 4th power divided by 2 to the 8th. Okay. And then we could multiply this out if we wanted to, or we could recognize, okay, this is 2 to some power down here. Is there a way to write 4 as a power of 2? And the answer is yes. 4 is the same thing as 2 to the power of 2, 2 squared, because 2 times itself gives us 4. So if I wanted to, I could even write 4 to the 4th as 2 squared to the 4th, right? Just replacing the 4 with 2 squared and then keeping that regular exponent of 4 on the outside. And then it ends up looking like this. And then watch this. We have an exponent with the 2, and then there's another exponent of 4 on the outside. And if you recall, when you have an exponent raised to another exponent or a power raised to another exponent, you multiply those exponents. So if we do 2 times 4, multiplying this exponent and this exponent, that becomes 2 to the 8th. And then on the bottom, we also have 2 to the 8th. And anytime you have the same thing on the top and bottom of an expression, that just equals 1. So this problem, if we simplify it all the way down, just gives us 1. Okay. One more of these. The expression -3m squared plus 15m is the profit for a rock concert based on the ticket price M. What is the most the promoters can charge per ticket and still make a profit? All right, so let's figure this out. If this is representing profit, okay, profit is the money that you have sort of left over after you've made money and paid your bills. Whatever's left over is the profit. Okay, the way we break that down is we say it's the income, the money coming in, minus the expenses, the money you are paying, your costs. So we have this function. Hopefully you can recognize that this is a quadratic function. And it's a special quadratic function because there is no number without a variable added at the end or subtracted at the end. It's just -3m squared plus 15m. This is very easy to factor, okay? This is one of these where we don't have a number to put in the bottom right of one of these models. Like if I put -3m squared in here, I would need a number without any m's down here. But we don't have one of those. And anytime you have a problem that's like that, where you don't have a number to put in down there, instead, you draw an area model with just 2. Okay, so instead of the 4 squares, we just put these 2 little models, and that's -3m squared and a positive 15m. So let's talk about what these have in common so we can factor it easier. If I factor this out, they both have an m, so I can put that in front, and they both divide by 3. Okay, because -3 divides by 3, so does 15. It divides by 3. And usually if your first term is negative, what you'll see happen is you'll often factor that negative out as well. Okay, that's just a common practice. If the x squared or m squared in this case is negative and you can factor that out, you just factor out the negative sign first. So we factor out -3m. That means we would need one more m factor up top to make the negative 3m squared when we multiply the sides. And then to get positive 15m, we already have the m in front, but we need to multiply negative 3 by something to get positive 15. That would need to be a negative 5, because a negative times a negative would give me a positive 15. So written in factored form, that original problem they gave us could be written as negative 3m times m minus 5. This side times this side. Okay. And now here's what we need to realize. This is a quadratic. It's got a negative number in front, which means it's opening down. It's going to look something like this. Okay. Basic shape like this. But I want to know, okay, where are the zeros? Where are the points where their profit is 0, right? If this represents the profit, if this equation does, then the zeros are where the profit is 0. Well, I can look right here at these factors, because remember, factored form helps you find zeros and x-intercepts of a graph very easily. So it's either the first part, negative 3m equals 0, or m minus 5 equals 0. We look at both factors. So negative 3m equals 0. If I divide both sides by negative 3 to get the m by itself, 0 divided by anything other than 0 is 0. So that means if we charge $0, our profit's 0. Well, that kind of makes sense. You're not going to make money if you don't charge people anything. And then if we come up here, m minus 5 equals 0, just add 5 to both sides, or you might be able to just think in your head what number minus 5 equals 0. And that turns out to be 5 as well. So then we have a 0 at 0 and a 0 at 5. And it opens down, so it's going to look something like this. So they're making a profit everywhere up here, and they're not making a profit everywhere below, right? So if they pick $5, that's the biggest price they can charge, but then their profit equals 0. If we want to actually make a profit and have some money, then we need to go just as little bit less than 5 as we can. And in terms of money, that would mean they should charge $4.99, right? Because that's as close as you can get to $5 without being $5. So because that's going to be in between the zeros at 0 and 5, that means that's the most we can charge and still make a profit. All right, so that wraps up this first review. If you have any more questions on that, just send me an email and I'll try to